We're going to be writing some code today to simulate two different real life things. First would be a traffic light, and the second will be, well, real life, but a TV show. It was the lights from this Knight Rider car. It was a famous TV show back in, I think, the late 70s, early 80s. So you'll see the LEDs go back and forth, kind of like this. I'm going to show you the code to do things similar to this, but in the end, you're going to be writing the code to make these two projects. Okay. All right. So things that we're going to need to do. Well, first, we're going to need to construct the circuit. First, when you're putting in the Arduino Nano, which can be the very first thing you put in, make sure that you're keeping so that you can see two holes down here and three up here. Okay, that should make it so that your breadboard looks just like you see it here. The connector should be to the left, so make sure that where you connect with the USB that's on the left. Also, all of these short legs that you see here in the picture, these are all the negative legs. So all the negative legs are going to end up in this row here, which is the blue column. And last, or almost last, this black wire is often forgotten, so don't forget it. It can be any color, same with any of these wires. What matters is that you get the wire going from the point that you see it in the picture to the other point that it goes to in the picture. So this could be a green wire or a blue. It doesn't really matter. It's just so that you get the wire as you see it here connecting from the same point to the same point. And lastly, the resistors, they should all be 150 ohms. So you need to make sure that you just double check, make sure they're brown, green, brown, and gold for all of these. Uh, and then just to kind of point out too, keep in mind how this breadboard worked, how these strips are interconnected. So there's a metal strip inside here that connects all of these holes together. So really, when you're constructing, as long as you have this leg and this leg of the resistor in the same row, or column, I should say, it'd be fine. So, like, if this leg happened to be up one, it'd be fine. Or if this leg was down one, it'd be fine. However, if you couldn't make it go a column over, that wouldn't be okay. So, if you want to just keep to sticking exactly to the picture, hey, great. But if you understand your breadboarding, you'll understand that even this green wire, instead of being in this hole, it could be in this hole, or this hole, or this hole. All right, pause the video and go ahead and get this circuit constructed with every single wire. When you're done, count 1, 2, 3, 4, 5. You should have 6 wires in total and 5 LEDs and 5 resistors. Now that we have our circuit constructed, we want to make sure that it is exactly connected as this is. And we'll test it and make sure that every one of the LEDs, in fact, lights up and turns on and off. So basically, we want to make sure that everything is right wiring wise. Uh, if something is not wired correctly, we're going to want to fix it now. If this test program works and these lights all successfully blink on and off, we'll know that everything is fine with the way that you have it wired. Okay. That said, you'll know that if something doesn't work when you write a program, that it's probably your program. Why? Because we're testing this right now to make sure that everything does work. Okay, so the only thing that could change, as long as you don't change your wiring, is your program. Okay, so here's mine. I have everything connected just like I did in the picture. I did use different colored wires as they had, but I have the red, the yellow, the green, and then I put the blue and the orange there. Okay, so in testing it, what we're going to do is take all of this yellow code here. So just get every single piece all the way down to the very, very last bracket. And then right click and copy that. And then we're going to open up our Arduino app, which again, if you need to go to search, you can start typing Arduino and you should find it. Okay. Once that gets opened up, we're going to take what's ever currently in there and highlight it all. So we can do that either by selecting it all like that, or Control A. I like Control A, and then I'm going to just delete it. And now we'll paste the stuff that we just copied. So I will Control V as in Victor, and that will paste the code that I just copied from Canvas. After I have that pasted in, I'm just going to double check, since this is my first time using the computer today, that we have it set up properly for the Arduino Nano. So we'll go to Tools, make sure that the board says Arduino Nano, make sure that this says ATmega 328P old bootloader. Make sure of that. And then for port, once you're plugged into the computer, you should see a highlighted one. Select it. Okay. All right. After those have been done, you're going to click this button here, which is Upload. The first time through, it's going to ask you to save it. If this is just a test, so I'm just going to call mine test and save. You'll notice here it says compiling, and now it's uploading, and when all is done, it should say done uploading, and if all went well, you should see the LEDs blinking on and off. So now I know that my LEDs are all working properly. So down here, this is kind of the workflow process that we'll be following. We're going to be writing our program using Blockly This should be this link should be used. The web URL is code.makewitharduino.com. Don't Google Blockly because it'll likely take you to the wrong one. You want this one, code.makewitharduino.com. There is another one which is similar, but we're going to be working with this. So now that we're in the editor, we're going to start writing our code. And we're doing that by using blocks, which if we click on any of these icons over here, will pull up a series of blocks that we can choose from. So we're going to start with input and output. Okay, and if we click on the little arrow down tab, we can see that we have a few choices: digital, analog, and others. We're starting with digital. Okay, now digital, we only have two choices when something's digital. Usually it's just on or off. Okay, so 0 and 1 essentially. So if you've ever seen those numbers 0 and 1 before associated with electronics, what they refer to as something being on or off, 0 or 1. And we'll kind of see that here when we're building something today. We're going to use this one right here on the bottom, or I'm sorry, wrong one. This one right here, digital write. Okay. Now, when I pull that in, it says digital write pin, and I can change this. And then this says status high. Well, we have our Arduino wired up so that when we make any one of the ports on the Arduino high, it'll turn on an LED. So if you look really closely on the chip, you'll see that there's printing. And over here it says D2 and then D3, D4, D5, D6. I have all of those ports, D2 through D6, connected up to these LEDs. So the first one, for example, is this red wire right here. All right, so this one's D2. If you follow it, it goes all the way over to here to this resistor, then through this resistor to the positive leg of the resistor, and then negative leg of the resistor is connected to negative. So basically, if we connect this end to positive, then the positive leg will have a connection through the resistor to positive, and the negative leg will have a connection to negative. It'll light up. So whenever I make port D2 high, it turns on the red one. If I make D3 high, it'll turn on the yellow. If I make D4 high, it turns on the green, and so on. If I make it a low, well, then it would turn the LED off. Why? Well, if the port were a low, that would mean that this is negative. So if a negative were connected through the resistor to the positive leg and a negative were also connected to the negative leg, well, both sides would be connected to the same place, negative. That wouldn't light up. So just remember, a high turns on the port, which will turn on the LED, and a low will turn off the port. Okay, so let's pick port 2. That is my red LED. So right now what will happen is it'll write what we call write a high to the port. So it'll make port 2 turn on. That's what that brick does. What I'm going to do is railroad lights. So I'm going to turn on the red one, and then I'm going to turn on, or I should say turn off, my green one. So they'll just alternate back and forth between red and green. So 2 is red. If I want to turn on a green one, I can pick another digital. I want the digital right, and I'll put it down here, and I'm going to say port 4. Why port 4? Well, again, port 4, if I were to look, port 4 connects through the green wire and connects over to this resistor and comes over to the green LED. So port 4 is the green LED and port 2 is this one. Basically, it's port 2, 3, 4, 5, and 6. So go back to my program. So when I have one on, or the red one on, which is 2, I'm going to have the green one off. Okay. And then we're going to flip-flop them because we want them to alternate. So I can just copy this by right-clicking and duplicating, and I'll do the same here. And we want to then flip-flop them. So this one now is low and this one high. So think about this for a second. Red one's on while the green one's off. And then for the other scenario, we want the red one off and the green one on. The second thing we need is a little time in between. Okay, if I were to put these two together, and I'll show you this, if I put them together like that, what will happen, run through this and do everything here, and then it starts back over, but it'll do it so quick that we won't actually be able to see any of these LEDs being on or off because they'll be turning on and off so fast as it goes through this. So we need to literally put a delay in there so that us humans can actually have time to see what's going on. Don't mind what I'm doing right now. I'm just going to show you that if I put this program in here real quick, that, oops, I forgot, that it will in fact blink those things so darn fast that you will not even notice that they're flashing. Wait till it uploads, and there you can see the red and the green. They both look like they're just on nonstop. So clearly that's not going to do what we want it to do. So we need to change the program a bit. So we have those two scenarios. Okay, again, red on, green off, red off, green on. We just need a delay between them. So I'll put in a delay here. This is a 1 second delay because the units are in milliseconds. Okay. And then I'm going to put another delay right there. So now what will happen is the red goes on, the green goes off, but then it stops in its tracks right here for 1 second. During that time, the red and green one, or the red will be on, green will be off. But then as soon as that second's done, it comes down to here, turns off the red one, and turns on the green one. And then it waits for a second and repeats. Okay, so if we do this little test program here, and you could copy this one, we'll upload this. So if you want to pause it now so that you can copy the code, go ahead. Now to program it, you're going to just click on that Arduino tab and get every bit of this code that's in here. And you can right click and copy it. And then we're going to go to our Arduino app. We're going to delete everything that's in there and paste, Control V, or you can right click paste, and that's our code. Now again, assuming we didn't change any of the settings, so it's Arduino Nano, old bootloader, and the COM port selected, we should be able to upload. So if I upload this program, I hopefully will see kind of railroad lights flashing between red and green. When you write a program, you're going to want to save it if it is working as intended. So this is the test program where we just did the railroad light. So if I want to save this and turn it in for a grade, which this one you don't have to, but you will some other ones, how can I do that? Simple. Come right over to here, and you want the cloud icon. And when you click that, it's just going to save a file and give it a generic name called Blocklyduino. If you click on the arrow, you can show it, and it'll show where it's saved. It likely is going to save in your downloads folder, okay, which you should see somewhere on the left if you click on downloads. Okay, you can see there it is, Blocklyduino. I can rename this by right-clicking on it and yours might be different. You can click rename, or for me, Windows 11, I click on rename, and then you can call it something like test or stoplights or whatever project it is that you're working on, and then just press enter. This is going to be the file that you're going to submit to me, and also one that you can come back to if you wanted to open up the program later. So if I were to do that, let me trash that real quick. You could see that if I click the upload or load button here, I just need to go to my downloads folder where I had the file saved, and there's test. And if I open it, it'll bring the blocks back up. So make sure that you know how to download the file, show it in the folder, and find it in the folder and rename it by right clicking rename and giving it an appropriate name. Must know how to do that. For credit, we're going to be doing these challenges. So we have the traffic light challenge here and the Night Rider challenge, and each one of these will be worth 5 points. And we need to understand exactly how what it's supposed to do before we write the program. So make sure that you do read and understand that. I picked the traffic light because everybody kind of knows that. The sequence should go green and then yellow and red, and it'll just repeat that forever and ever. I want you to have the green on for 5 seconds, and then, of course, the green one would turn off and the yellow one would go on, and then the yellow would turn off and the red one would go on for 5 seconds, and then it would repeat. So they'd just be going over and over again, green, yellow, red, for the times indicated. So what you're going to need to do is make sure that you tell it exactly what to do in each step. So you'll need the right block, and you'll be able to make the LED on or off by changing this to high or low. You're going to need delays in there. You're going to need several of them. You'll need several of these bricks and several of these to accomplish this task. So go ahead and work on putting the correct blocks into Blockly using the digital and time blocks to accomplish that. And then for the Night Rider challenge, we want to understand what that does. This is just going to move the LEDs back and forth, kind of like you see right here. There's only going to be one LED that's ever on at any one point in time, and they're just going to keep going back and forth and back and forth. So really, it's a process of just turning on and off the correct ports in the correct order, and of course using some delays in between those times. The delay time, which will be how fast it goes and changes the LEDs, that's up to you. Uh, Maybe 100 milliseconds would be a suggestion. So just understand what has to happen. It's back and forth between LEDs D2 to D6, and then back from D6 to D2, so over and over. Once you make those, make sure that you download them and rename them so that you have them so that they can be turned in.